All right, so on the back of here, we have more of the same, except now they're giving us the equation, and we're graphing the line. So like on the back, we started by finding the b. Here we're going to start with the b as well. We're going to look at the b value in the equation. What's the b value for the first one? It's positive 3. What's the b value for number 17? Negative 1. And what's the b value for number 18? Positive 6. What you could do is start by placing that point on each of these graphs. This one, I'm going to go up 3 and put my first point. 1, 2, 3. That's my starting point for that line. For number 17, I'm going to start at the origin. I'm going to go down on the y-axis and put my first point. That is my b value. That's my y-intercept for number 17. For number 18, what do I do? Starting at the origin, where do I go? Up how many? Up 6. Very good. 2, 4, 6. I mean, technically, it doesn't look like you're halfway done with your line, but you're pretty much halfway done with your line. You've gotten the b value all plotted. The m value is the one that goes over and over. That's my stair-step number. So, problem. I don't have 2 numbers. I'm supposed to have a top and bottom number, but this only has a 2. What do I do? If you only have a whole number for your slope, the bottom number is automatically a 1. For this one, I don't have to put a 1 because that says 1/3. So I'm going to put 1 over 3. And, oh, I don't even have a number for number 18. What in the world? What is that?
Minus 1.
Minus 1, but I don't have a bottom number. What's my bottom number? The bottom number is not negative 1. The reason is, if I have both negatives here, top and bottom, they would divide out to give me a positive slope, but that is not a positive slope, right? So we want to keep the negative with just the top and just put a 1 on the bottom. All right, so starting at my beginning value of 3, I'm going to go up 2, 1 to the right. And remember, when you plot slope, it's not the same as doing ordered pairs. We're not starting at the origin. We're starting at our beginning value, our y-intercept. So I start at the y-intercept, and then I do my stair step. Up 2, over 1, put a point. Up 2, over 1, put a point. From there, you can use your straight edge, or if you're comfortable doing it, you could do what I call opposite counts. If I'm going this way, which is the way I like to go, I'm going up and right. So going the other way, I go down and left. And if that confuses you, don't worry. Just use your straight edge. The way you know if you're getting it correct or not is if you make a V or something weird instead of a straight line, you know that you weren't doing your counts correct. But the way to for sure get it right is just use your straight edge. So there's the line for that one. So now I have my negative 1 for number 17. It's a positive slope. I'm going to go up how many?
1.
And then how many to the right? 3. So up 1, 3 to the right. There's my point. Up 1, 3 to the right. There's my point. And then from there I can use my straight edge and get the whole line. Oh, I could put this in the calculator, yeah. You can put this in the calculator to check your work. That's a good, I'm glad you brought that up.
No, just to get the graph.
If you wanted to, a good strategy, if you want to make sure, you could put this in the calculator and then pull up the table and you could just plot ordered pairs from the table and you'd have everything you need. That'd be another way to do this. Yeah, my line's kind of crooked there. Let me go up there. Okay, number 18. We went up 6 already, and now this is down 1, 1 to the right. So down 1, 1 to the right. And you keep doing that. Now, why does number 18, the line's going different? It looks different than 16 and 17. What's going on? This guy's going that way, this guy's going that way, and this guy's opposite. Why? Yeah, the negative slope makes it go downhill. We always read it left to right. This is uphill. That's a positive slope. This is uphill. Now, why is this one not as steep? Is there a reason? Yeah, 2 is a much bigger number than 1/3. Like 2 pizzas, that's a lot of pizza. 1/3 of a pizza, that would barely feed me, right? I'd still be hungry probably. I eat a lot of pizza, right? And then, so that the smaller the slope, the closer it is to being like a flat line. The steeper the slope, the more steep, the bigger the slope, the more steep it gets, closer to being a vertical line. And then if it's negative, it just flips it to where it's going downhill. Okay, so we've covered finding the slope and the y-intercept in equations. We've covered writing the equations when they give you slope-intercept. We've covered finding the slope and the y-intercept in a graph. We've covered graphing a line when they give you the equation. We've covered all those. And now we get to do a couple of word problems, not too many. Whenever you're doing word problems, we remember to P, remember per, each, and every, help us find what? They help us find the M or the B? They help us find the M. And these are available to you guys. Per, each, and every, help us find the M. On this little reference paper I always pull up, everything in blue is talking about the slope. So per, each, and every, that's in blue. It's talking about the M. All right? So somebody read number 19 for us. Go ahead, Alejandro.
Hudson is already 40 miles away from home. On his drive back to college, he is driving 65 miles per hour. Write an equation that models the total distance D traveled after each hour.
Perfect. That was great. Now, I want to point out, there's no word per, each, or every in there. But when Alejandro read it, he did say the word per. Did you guys notice that? Miles per hour. And that's exactly right. So, if you can identify that, that's the word per. And what's the closest number? The 65. That is my M. Now, does it make sense? It does make sense. The B is where he started. And he started 40 miles already on his trip, right? So that's his starting number. That's his B number, the 40. The M, the word per is right there. It's kind of hidden. It's actually the slash, but you read that miles per hour. That's your 65. That's your M value. Because every hour he goes, he's gone 65 more miles. That is your Dixie and Roy D relationship. Let's write that word fraction, miles per hour. Which cow is always on top doing the painting? Roy D, yeah. Miles in this situation, that is your Y data. The data in the table, when you look at the Y side, that's the number of miles he went. You input the number of hours he's been driving, that's your Dixie value. The output is the number of miles he's driven. And our equation is Y equals 65x plus 40. Now I want to point out something. We use Y and X, but they don't want us to use Y and X. I think it's totally good to use Y and X, but what if you're taking a test and none of the answer choices have Y and X, they have D and H? Well, using the word fraction helps you find which one is which. Miles is my distance, and hours is the bottom one, right? So this is my Y, distance is my Y, and hours is my X. It's always Y over X, right? So instead of Y equals 65x plus 40, it could be D equals 65H plus 40. It's the same thing, just using the variables that they want us to use. Now, for the homework's sake, you could do either one of those, and we're going to count it right. All right. Who wants to read 20? Go ahead. That'll be awesome.
When Bill started his new job, he owed the company $65 for his uniform. He is earning $13 per hour. The cost of the uniform is $7,000 from his earnings. Write an equation that models the total of money he has after each hour of work.
So again, they have different letters, but we're still going to use X and Y at least to start off with, because that's kind of what we're used to. Anybody find the word per, each, or every?
13.
Yeah, $13 per hour. So is that going to be the M or the B? Very good. Now, this one's a little tricky. Is he making the money or is he spending the money with the 13?
Spending.
With the 13, he's working a job, right? He's making the money.
Minus 65.
Very good. So the 13's positive. He's making that money every hour. But the 65 is money that he owes. So that has to be negative 65. Those little details are important that you have to pull that out of the vocabulary. It's not always obvious just by looking at the numbers. Since he owes the $65, that's the negative one. That's the B. So he's starting $65 in debt, basically. He's got to work a few hours just to get up to zero, and then after he gets to zero, any more hours he works, he starts making money. Make sense? Yeah, he is. Okay, we're almost done. The very last section, guys, is just math manipulation, where you just have to get y by itself. Y is not by itself on any one of these three. But once you get y by itself, it becomes as easy as the very first section. On the very first section, y was by itself, and you just pick out the m and the b. Once you get y by itself on these last three, it's just like section 1, okay? So I have here y plus 4 equals negative 6x. I need to get the y by itself, so what do I move over? Yeah, I do minus 4 on both sides. That cancels. I have y on the left. And it doesn't honestly matter what order you write it in, but since I'm kind of thinking in terms of mx plus b, I'm going to write the negative 6x first. Do you have to? Not really, as long as you know which is which. Now that I have y by itself, which one is the m value? Negative 6. And which one is the b value? Negative. Remember, it is negative 4. It's not just 4. That little minus sign is a negative on that 4. Okay? Number 22. Y equals half x plus negative 4. Here's my wall. What do I do? We could, but that might actually make us have more work because we want the y by itself. You could move this guy. Yeah, minus the whole thing, 1/2 x. You can get rid of the whole thing. Now, I wanted to point out on number 21, notice what I didn't do. I didn't do negative 6x minus 4 gives me negative 10x. How come I can't do that? Yeah, this guy has a variable and the 4 does not have a variable. They don't have the same last name. They're not like terms. So we have to keep them separate. Same thing here. When I wrote my minus half x on the right-hand side, I purposely didn't even put it underneath the negative 4 because they're actually not even like terms. So I can't put those together. What I can do is just write negative half x and then put minus 4. So now I have y equals negative half x minus 4. My m value is what?
Negative 1/2.
The negative 1/2. Notice I'm not writing the x every time I ask for the slope, the m value. It's not the x. The x is something totally different. The slope, which is what we call the m value, it's the number in front of the x, not the x itself. The b value is this other number, and I got to remember that negative in front. Again, there they are. What's another word for slope? What's another word for m value besides slope and over number? In a word problem, you tend to call it the rate of what?
Change.
Rate of change. Because remember, it's the one that's changing. It's always making your line go up and over, etc. Now this last one has a few more steps. Okay, here's my 3y. I'm going to put a little box around it. I might want to move everything over there. My minus 12x becomes plus 12x. My plus 6 becomes minus 6. So that cancels, that cancels. That 0 doesn't really do anything. I don't have to write that anymore. I have 12x minus 6. But I'm not done. I have 3 with my y. How do I get rid of the 3? Divide everything, both sides, by 3. That cancels. And here I have two short problems. 12 divided by 3 is 4, so I have 4x. Negative 6 divided by 3 is negative 2. So I have y equals 4x minus 2. And my m is 4 and my b is negative 2.